Alright, lap joints. To make a weld lap joint with a vertical position, you should move the electrode in with a triangle weaving motion shown in figure 737 view E. Use the same procedure outlined above with the T-joint, except with the direction of the electrode moved more toward the vertical plate marked G. Hold the arc short and lightly at the surface of the plate of the G, with try not to undercut with the ease of the edge or two, with the allow with the molten metal with the overlap of the edges of the weave. Lap joints or heavier player may require more than one bead. If it does, clean the initial bead thoroughly. Place the subsequent beads as shown in figure 737. View F. Precautions to ensure the good fusion uniform weld deposit with the previously outlined for the T-joints, so it applied to the lap joints. Alright, butt joints. Prepare the plate as used with vertical welding identically. Prepare for the welding with a flat position obtained with a good fusion penetration. No undercutting. You should hold a short arc, and motion of the arc should be carefully controlled. Butt joints are beveled 1/4 inch thick and can be welded in one pass by using a triangular weave motion shown in figure 738 view A. Welds made with 1/2 inch plate heavier should be in several passes shown in figure 738 view B. Deposits of the last pass of the semicircular weaving in the motion with a slight whip up and because of the electrode at the edge of the B that produces a good cover pass. With no undercutting welds made on the plates with the backup strip should be done in the same manner. The E7018 electrode welding technique, previously described vertical welding technique, generally covers all of the types of electrodes. However, you should modify the procedure slightly when using the E7018. The vertical down welding, you should drag the electrode lightly using a very short arc or refrain from long arcs since the weld depends on molten slag. For shielding, small weave stringer beads are preferred to the wide weave pass, higher amperage AC than DC. Point the electrode straight into the joint and tip the forward only a few degrees for the direction of travel. Open vertical on vertical up welding. Triangular weave motion produces best results. Do not use whipping motion. Remove the electrode from the molten pole. Point the electrode straight into the joint and slightly upward in order to allow the arc force to help control the puddle. Adjust the amperage in the lower level of the recommendation range. Overhead position welding. Overhead welding is the most difficult position in the welding. Not only do you have to contend with the forces of gravity, but the majority of the time you also have to assume the awkward stance. Nevertheless, the practice is possible to make welds equal to those made in the other positions. Current setting and electrode movement. To retain complete control of the molten pedal, you with a very short arc. Reduce the amperage as recommended. As in vertical position of welding, gravity causes the molten metal to drop and slag from the plate. When too long of an arc is held, the transfer of the metal from the electrode to the base metal becomes increasingly difficult. The chance for the large globes of the molten metal dropping from the electrode increase. When you routinely sharpen or lengthen the arc, the dropping of the molten metal can be prevented. However, if you defeat your purpose, you should carry out too large a molten pool of metal to be in the weld. Once the problem is encountered, overhead welding weight of the cable to reduce the arm wrist fatigue. Drop the cable over the shoulder when the welding is standing position. When sitting in place, cable over the knee. With experienced cable placement will become second nature. Warning: because of the possibility of falling molten metal, use protective garment with a tight-fitting collar over the bottoms of zip up and the tip of the neck. Roll down your sleeves and wear a cap and appropriate shoes. Type of welds. Technique used for making bead welds, butt joints, fillet welds, overhead position are discussed in the following paragraphs. Bead welds. For bead welds, the work angle of the electrode is 90 degrees for the space metal, and the travel angle should be 10 and 15 degrees for the direction of the weld. Weave belts can be made by using motion shown in figure 739, and a rather rapid motion necessary to end with each semicircular weave to the control of the molten metal deposit. Avoid excessive wear because it can cause overheating of the weld deposit, formation of a large uncontrollable pool. Alright, butt joints. Prepare for the plates for the overhead butt welding in the same manner as required for the flat position. Best results are obtained with the backing of the strips used, and however, you must remember when you will not always be able to use the backing strip when you bevel the plates with the feather edge. You do not use backing strip when the wedge is repeatedly burned through unless extreme care is taken by the operator. For overhead butt welding, bead welds are preferred over weave belts. Clean each bead, chip out the rough layers before placing the next pass electrode position or deposition of the weld beads with a welding of 1/4 inch or 1/2 inch plate is shown in figure 740 view B and C. Make the first pass electrode held at 90 degrees to the plate is shown in figure 740 view A. When you start to use the electrode that is too large, you cannot hold a short arc in a root area with the result insufficient root penetration in inferior joints. Alright, show figure 739 shows the position of the electrode, weaving motion, and overhead position. Then you see A and direction B. Then it shows a multi-pass butt joint overhead position. You have it at 90 degrees, then the stacking of the beads. Alright, your fillet welds are making a fillet weld, either T or lap joint overhead position, maintain short arc, refrain from weaving of the electrode. Shows the stacking 1, 2, 3, and 4. Not which direction of welding, motion of the drawing arc outside slightly with the crater to allow metal to solidify. Direction of the vertical plate. Direction of welding angle. Hold the electrode approximately 30 degrees to the vertical plate with a move uniformly with the direction weld shown in figure 741. View B. Control arc motion, good penetration root of the weld, good fusion, sidewalls, vertical, horizontal plate. When molten metal becomes too fluid and tends to sag, whipping the electrode quickly away from the crater, avoid to having lengthening with the arc, allow the metal to solidify, immediately return the electrode to the crater, continue welding. Overhead fillet welds, either T or lap joints on the heavy plate, require several passes of the beads to complete the joint. One example of an order of bead deposition shown in figure 741 view A. The root pass is string bead made with no weaving motion on the electrode till the electrode is about 15 degrees from the direction of the welding is shown in figure 741 view C with a circular motion, making second and third, fourth passes of the motion. Electrode permanence grade with the control with a better distribution weld metal with the remove all slag oxides from the surface of each pass, shipping in wire brush after applying additional beads to the joint. And this shows causes and cure common welds. You have a porous weld, cracked welds, poor penetration, poor appearance, warping, poor fusion, undercutting, brittle welds, spatter, and magnetic blow. Welding difficulties. Many of the welding difficulties, metal arc welding is the same as the oxygen gas welding. For as few such problems, undercut, crack welds, poor fusion, complete penetration. Table 7.3 provide illustration of most of the common welding problems encountered during the arc welding process. Methods to correct them. Every welder has a responsibility making each of the best of the one as properly to produce quality welds adhering to the rules that 1. Use only high quality welding machines, electrode welding accessories. 2. Know the base material that you're working with. 3. Select the proper welding process that gives the highest quality for the base material used. 4. Select the proper welding procedure that meets the surface requirements of finished weldment. 5. Select the correct electrode for the job in the question. 6. When preheating specified required you meet the temperature requirements in any of the cases. Do not weld material that is 32 degrees Fahrenheit without first preheating. 7. Clean the base metal. All slag, paint, grease, or oil, moisture, or any other foreign material. Remove the weld slag thoroughly. Clean each bead before making the next bead or pass. Do not weld over the cracks, pores, tack welds. Remove the defective tag welds before welding. Be careful, particular alert with the obtained root fusion on the first pass, fillet, and groove welds. 11. When the groove weld and weld root gaps are excessive, build one side up of the joint before welding the pieces together. When fillet weld root gaps are excessive, be sure of the increase of the size of the fillet weld to the size of root gap to maintain strength requirement. In some cases, the advantage is to make with the groove weld, but I avoid extremely large fillet welds. 13. Inspect the work after completion immediately and remove the replace the defective weld. Observe the size of the requirement for each weld to make sure that they meet and slightly exceed the specified size. 15. Make sure the finished appearance of the weld is smooth, the overlaps, undercuts, and has been repaired. Pipe welding. Welding is the simplest, easy way to join sections of pipe. This need of the compliant joint design. Special threading equipment is eliminated. Weld-in pipe has reduced flow restriction compared with the mechanical connections overall installation costs are less. Most popular method of the welding pipe, the shield metal arc process. However, the gas shield arc methods have the big inroads as a result of the new advance of the welding technology. Pipe welding has recognized the professional in itself, even though many of the skills are comparable with all the other types of the welding pipe. Pipe welder developed skills uniquely only to the pipe welding because of the hazardous material that most pipe lines carry. Pipe welders are required to pass specific tests before they can be certified. Following paragraphs, pipe welding positions, pipe welding procedure definition related information are discussed. Pipe welding position, you may recall Chapter 3 of the manual within the 4 position of the pipe welding known as horizontal rolled position 1G, horizontal fixed position 5G, pipe inclined fixed 6G, and vertical position 2G. Remember, these terms refer to the position of the pipe and not to the weld. Pipe welding procedures. Weld cannot be made in a single pass, should be made in interlocking multiple layers, not less than one layer, each 1/8 of an inch pipe thickness. Deposit each layer with a weaving oscillation motion to prevent entrapping slag in the weld metal. You should clean each layer thoroughly before depositing the next layer. And then it shows figure 742 shows butt joint socket fittings, butt joints, and elbows. Butt joints are commonly used between pipes and welded fittings. They also use the butt welding flanges, welding stubs at making butt joint 2 pieces of pipe to end, allowing them welding. The wall thickness of the pipe 3/4 inch or less. You can either use a single V or a single U type bullet joint. However, the wall thickness is more than 3/4 of an inch. Only a single U type should be used. Fillet welds are used over the welding slip-on threaded flange pipe. Depending on the flange, the type of the surface, the fillet welds are required both of the sides of the flange combination bevel weld. 734 fillet welds are used with the welding screw with the socket coupling with the pipe. To use the single fillet welds, figure 742. Sometimes fillet welds requires figure 744. Show one type of the flange square to use in the vertical horizontal alignment. Another form of the fillet weld used with the pipe fitting is in sealed weld. Sealed weld is used primarily to obtain tightness. To prevent leakage, sealed welds should not be considered adding strength to the joint. Alright, fillet welds on flanges, fillet bevel welds on slip-on flanges, flange connection. 744 shows flange alignment. Joint preparation, fit up. Just carefully prepare pipe joints of welding if you can want good results. Clean the weld edge surface with all loose scale, rail, slag, rust, paint, oil, other foreign matter. Ensure the joint surface is smooth and uniform. Remove the slag with the flame cut edges, however, if not necessary, remove the temper color. When you prepare joints welding, remember the bevels must be cut accurately. Bevels made with a machine grinding using gas cutting torches. In-field work welding operator usually must make bevel cuts with a gas torch. You can believe the beveling and cutting always little possible to allow for the complete fusion penetration beveling. Proper beveling reduces the amount of filler metal required, and which in turn reduces the time, expense, in addition to all means less strain in the weld. Better job of designing in the weld. Lining the pipe before welding, maintain in alignment during the welding operation. Maximum alternate alignment tolerance of 20% pipe thickness. Ensure proper in initial alignment. You should use clamp figs and holding devices. A piece of angle iron makes a good jig for a small diameter pipe with a section channel or an I-beam more suitable for a larger diameter pipe. Alright, tack welding. When one material solidifies, you may tack weld to hold it in place integrity. Tack welding is one of the most important steps of the pipe welding. Any other type of the welding, number of the tacks are required depends on the diameter of the pipe. For 1/2 inch pipe, you may need 2 tacks placed directly opposite of each other. There is a rule: 4 tacks are adequate for a standard size pipe. The size of the tack weld is determined by the wall thickness of the pipe. Be sure that the tack weld is not more than twice the pipe thickness. Length of 2/3 of the pipe thickness. In depth, tack welds should be the same quality of the final weld. Ensure that the tack welds have good fusion and are thoroughly cleaned before proceeding to the weld. Spacers. Addition tack welder spacers sometimes required to maintain proper alignment. Spacers are accurately machined pieces of the metal for the form of the dimension of the joint designed to use. Spacers are sometimes referred to as chill rings, back rings. They are several number of purposes to provide means for the maintaining specified root opening, provide a convenient location for the tack welds, and aid in the pipe alignment. Additional spacers can prevent welding spatter and the formation of slag icicles inside the pipe. Electrode selection. Select the electrode best suited for the position type of the weld to be done. For the root pass for the multi-layer weld, you need an electrode large enough you're not exceeding 3/16 of an inch. Ensure the complete fusion preparation without undercutting and slag inclusion. Make certain when the welding current is within range of the recommended manufacturer of the welding machines and electrode. Weather conditions do not summon the welder to a job under any following conditions just below. Thus the welder and the work area are properly protected. Atmospheric temperature less than 0 degrees when the surfaces are wet, when rain, snow is falling, moisture, and the condensing of the welding surface during the periods of high wind at temperatures between 0 to 35 degrees Fahrenheit. Heat in the welded area within 3 inches. Heat the welded area with 3 inches of the joint with a torch to temperature warm to hand. To warm to the hand, begin welding. Wear facing. The CB welder can greatly extend the life of the construction equipment due to the wearing face of the procedure. The wearing face is the process of applying with a layer with a special composition metal onto the surface of another type of the metal for the purpose of reducing wear with the selection of the wear face alloying for applications based on the ability of the alloy to withstand impact abrasion. Impact refers to the blow and series of blows to the surface of the result of the fracture, graduation, deterioration. Abrasion is grinding action results of one surface slide rolls and rubs against another under the high compressive loads. The action can result in the gouging. All alloys of the abrasion resistant or poor withstanding impact conversely through those withstand impact well or poor resistant abrasion. However, there are many alloys whose wear facing properties are available between the two extremities. These alloys offer some of the protection against abrasion and withstanding impact well. Workpiece preparation. Before you wear a face workpiece, oil, dirt, and oil, rust, grease, and other foreign material must be removed. If you don't, your finished product will be porous and subject to spalling. You also need a solid foundation, therefore repair all the cracks and remove any of the metal that is fatigued or rolled over. Preheating, depending on the type of the metal, sometimes it's necessary for the preheat of the base metal. The less distortion prevents spalling with the cracking to avoid the thermal shock. Preheating temperature depends on the carbon alloy content of the base metal, but in general, the carbon content increases with the preheating temperature. Improper heating can adversely affect the metal, reducing resistance to wear by making it hard and brittle, and by making work prone to oxidation. Scale. To preheat properly, you must know that the composition of the base metal with the magnet can be used to determine if you're working with carbon steel with the austenitic magnesium steel. Carbon steel is magnetic, but carefully because the work-hardened austenitic magnesium steel is also magnetic. Make sure that you check with the magnet and non-work part of the austenitic magnesium steel. There are other ways to tell the difference between metals such as cast iron, cast steel. Cast iron chips or cracks, while steel cast shields shaves. And also some metals give them telltale sparks when struck with a chisel. Preheating should raise the surface temperature of the workpiece for the desired point with the choke until the heat reaches its core. After wearing face, cool workplace slowly. Alright, techniques when possible. The position of the workpiece, the down hand welding. This allows the finish of the job quicker and less call for the building of the wear face cast iron. Is generally recommended with the cover of the cast iron tin with the crack. However, some of the cast iron parts, subject to straight abrasion from wear surface successful. Wear face successful. Most preheat in the parts of the temperature of 1,000 to 1,200 degrees Fahrenheit. Allow the cool so after the wear facing. Painting deposits on cast iron helps to relieve stress after welding. Welding materials build up the worn parts of the differ from those of either the wear facing with the same parts before the wear facing and a body worn part. When they may first build up 3/16 of an inch to 1/8 of an inch of the finished side of the build up of the material the most compatible with both the base metal with the wear facing overlay as well with being strong enough to meet the structural requirements. Also, they must have the properties to enable these to resist cold flowing, mushing, the high compressive loads, and plastic deformation under heavy impact. Without these properties, the first build-up material then cannot support the wearing face overlay. When the overlay is not properly supported, it will span. Many times, high alloy wear-facing materials are deposited with the parts before they are plated into the maximal level of wear, and usually no more than 2 layers deep, 1/4 inch, and before wear-facing. Try to deposit wear-facing alloy in the layers not too thick. Thick layers can create more problems. No overall at all. You only need for the 2 layers frost layers produce. Add a mixture of the base metal and second forms of wearing resistant surface. And wear facing built-up carbon steel parts maintain higher inner pass using weaving bead rather than stringer bead. Limit the thickness of single pass bead to 3/16 of an inch using the same technique. Each layer avoids severe quenching. Deposits made in the high alloy electrodes should be checked out with the surface and checked with the reduced residual. Alright, 747 through the comparison, cross-checking, cracking. Cross-checking, base metal, hard metal, cracking, base metal. 740 wear-facing bulldozer end bits. 749 wear-face shovel teeth. For dirt and clay or sand, for rock. It shows waffle cross hatching. Without locked in stress, without checking the combination of recital stress, survey the stress mix, either the tensile streak with a cover the deep track or spalling, because be sure to induce the checking it does not occur. If it does not occur. Naturally, unlike any of the occur, large parts of the heat build up, you bring on the checking spray with sponging the deposit of the wet cloth, spraying it with a fine mist of water. Also, you speed up the checking by occasionally striking with a hammer while it's cooling, while checking it free with the deposit required. Use the softer alloy, just preheating post-heating requirements. Bulldozer blades are wear face in place at the end of the pits of the flat position welding beads across the outer corners along with the edge. Be sure to preheat the higher carbon blades with a wear facing on worn end bits. Weld the new corners on the wear face. Figure 748. Shovel the teeth wear face. Shovel the teeth when you are new before placing in the surface of the welded B pattern. Use the wear facing have them marked after the surface life of the earth. When wear face, shovel the teeth have the work mainly in rocks with beads. Running the length of each tooth that allows the rock to ride on the hard metal beads. Teeth that are primarily used to work in the dirt, clay, and sand should be wear faced with beads running across the width of each tooth perpendicular with the direction of the material that flows past the teeth. This allows material to fill spaces between the beads and provide more protection to the base metal. With another effective pattern is the waffle or crosshatch. Wearing face is laid on top inside of each tooth and 2 inches from its point. Stringers are behind beads behind a solid deposit reduced wash. Alright, this shows composition wear facing patterns on shovel teeth. The best, not so good, not so good. Alright, table 7.4 shows the recommended electrode size, current size and current speed, carbon arc welding, different thicknesses, steel plate. Alright, more information on the wearing face application may be obtained with the NTF Welding Materials Handbook, Navy Fact P43, 3 carbon arc cutting. Most carbon cutting cleanly. Carbon electrode becomes non-formed metals are introduced at the arc. Cutting current should be 25 to 50 amps above the welding current, same thickness of the metal. Carbon electrode point should be grounded with a very sharp during the arc cutting. Actual cutting move of the carbon electrode vertical elliptical movement into the undercut of the metal. This aids the movement removal of the molten metal. As an oxygen cutting, the crescent motion is preferred. Show the relative position of the electrode and working on the cutting cast iron, figure 752. Carbon rod direction, progress, slag, undercut, and motion, cast iron, positive, negative. Carbon arc method of cutting is successful with the cast iron because of the arc temperature high enough to melt the oxide form, and especially important with the undercut of the cast iron curve to produce an even cut. Position the electrode with the molten metal flows always gouging cutting areas. Table 7.4. A list of the cutting speeds, plate thickness, and current settings of the carbon arc cutting. Because of the high currents required for the graphite with the carbon electrode to reduce the heating of the effect of the electrode, you shall not let it extend more than 6 inches beyond the holder of the when cutting. If the carbon burns away too fast, short in the length that in the extent of the electrode holder to as little as 3 inches. Operating carbon electrode extreme high temperature for the cause of the surface of the oxide burn away, resulting in a very rapid reduction in electrode diameter. Carbon arc cutting does not require special generators. Standard arc welding generators. Other items are arc welding station equipment that is suitable for the use of the straight, polar, direct current is always used. Because the high temperature and intensity of the arc could use a shade of the helmet lens. Use the darker the normal shade. You would use the welding on the same thickness of metal. Number 12 or 14 lens should be recommended with the carbon arc welding cutting. Alright, air carbon arc cutting. Air carbon arc cutting is the process of the cutting a piece of the gouging metal, heating it into molten state, then use the compressor to blow away the molten. Middle figure 753 shows the process equipment that consists of the special holder shown in figure 754. Use the carbon graphite electrodes, compress air through the jet built as electrode holder, push belt and button over on the hand valve electrode control of the air jet. Figure 753 shows the air carbon arc cutting arc stream direction travel carbon electrical holder air jet. The air jet blows the molten metal, usually with leave the surface and leave the further preparation for welding. Electrical holder operates the air pressure varying between 60 to 100 psi gauge. Now use a bare carbon graphite electrode becomes smaller of the oxidation caused by the heat buildup of the copper coating of these electrodes. You reduce the heat with the buildup of the prolonged their use. The operating procedure for the air carbon arc cutting gouging basically the same. The procedure is followed with just the machine to correct current with the electrode diameter. Start the air compressor to adjust the regulated correct air pressure. Use the lowest air pressure possible to adjust enough of the pressure to blow out a wave of the molten metal. Insert electrode into the holder. Examine the carbon electrode 6 inches beyond the holder. Ensure the electrode point is properly shaped. Strike the air opening the air jet valve with the air jet disc and swivel the V groove at the end of the disc. Automatically align the air jet along with the electrode. Electrode is adjusted relative to the holder. Control the arc and the speed traveled according to the shape of the condition with the cut desired. Alright, 750 short force shift the air carbon electrode holder with the carbon electrode installed. Airflow, air jets, carbon electrode, air valve, electrode can lamp, lever, combination air hose, electrical lead. Alright, figure 755 shows the V groove with the 2-inch thick carbon steel. Always cut away from the operator. The molten metal sprays distance of the carbon. Cutting the action, you may use the process to cut gouge metal flat, horizontal, vertical, overhead position. Alright, air carbon arc gouging. Air carbon arc gouging, useful many various metal working, application of the metal, shaping together, welding, preparation for gouging, holding electrical holder, electrode shapes, slopes back with the direction of the travel of the blast and direction along with the electrode, torque with the arc, depth of the contour of the groove, control with the electrode, angle of travel, speed with the groove is governed by the diameter of the electrode. When cutting a gouging shell, groove with the surface of the plate, piece of the metal, you should position the electrode holder very flat angle relating to the work. Speed travel, though the current setting allows for the depth of the groove, the slower of the movement, the higher of the current, the deeper the groove. And in the example, the V groove that are made in 2-inch thick metal, mild steel blade with a machine guided carbon arc air jet is shown in figure 755. Alright, 756 shows the steel electrode being used to cut the plate and positive electric airstream, the gas jet electrode cover, the electrode negative covering steel curtain curve. Metal electrode arc cutting. Metal can be removed the standard electrical arc for gouging or cutting result, and you should special metal electrodes have been designed for either the type of work manufacturer design. Developed electrodes with special cuttings intensity arc stream, rapid cutting cover and disintegrate with slower rate with a metal helix center. Creates a deep receives of the produced jet action, blows molten metal away. Figure 756 shows the main advantage for these electrodes. Additional metal produced must be removed. Electrodes are designed to cutting stainless steel, copper, aluminum, bronze, nickel, cast iron, magnesium, steel, and alloy steels. All typical gouging cutting operations shown in figure 757 notes the angle between the electrode and the plate is small and 5 degrees or less. That makes it easy to remove the extra metal produced by the electrode. Alright, the recommended current setting with the high of the electrode will take with the overhead to even the point of the cracking covering 1/8 of an inch electrode setting ranges between 125 and 300 amps. For 532 of an inch electrode setting range of 250 375 amps, 365 inch 3/16 of an inch electrode setting range between 300 and 400 amps. Use a very short arc when cutting takes place in the underwater. The coating must be waterproof. Figure 537, 757 shows gouging, cutting operation, solid arc, cutting electrode. Welding quality control and fabrication requirement equipment tests you to determine the quality soundness of the welds. Many different tests have been designed special for all the type of the even depends upon the requirements of the weld available to test equipment. In this section, non-destructive testing are briefly discussed. Non-destructive testing and non-destructive test method of testing do not destroy or impair the usefulness of the weld within the test of disclosed all common internal surface defects that can occur in proper welding procedures. Use the large choice of the testing device available. Most of them are easier than use of the destructive methods, especially when working on large and expensive items. Visual inspection will be done automatic by the welder completes his weld, but strictly a subject of the type of the inspection. Usually, if there are no defined ranges limits of the acceptability, the welder may use templates or weld bead contour check. Visual inspections become basically comparison finish weld with accepted standards. Test effective only with the visual quality of the weld. Our most important magnetic particle inspection. Magnetic particle inspection most effective with the detection surface near the surface flaws in the weld. And then issue the metal alloys in which induce the magnetism. The test bead for the magnetized liquid containing fine ground iron powder is used. Is applied along its magnetic field that is not distributed. Iron particles will form a regular pattern surface of the test bead for the magnesium field interpreted with the crack of some of the other defect of the metal. The pattern of the suspended ground metal is also interrupted with the particular plate of the cluster is also the effect of the metal, making it easy to locate. You can magnetize the test piece either having an electrical current pass through it, shown in figure 758, or by having an electrical current pass through a coil or wire surrounded with the test of the piece, shown in figure 759. 759 direction of current prod, section of pipe, circular magnetic lines of force, iron particle indication detect. Shows the longitudinal magnetism, direction of current, iron particle indication detect, longitude, magnetic lines of force, section of pipe. Forces are circular direction, shown figure 758, with the current flow through the cool around the test piece, shown figure 759, metallic lines are longitudinal through a TSPs. With a defect show up with the disturbance of the pattern of the iron particle, the direction of magnetic field must be at a right angle with a major axis of the defect, with the magnetic field of the defect in the necessary direction established with the current flow parallel major axis of the defect. Since the orientation of the defect is unknown with the different current dimensions must be either during the test, shown figure 758, current circular magnetism into the test piece, so you can inspect with a piece with lengthwise cracks, longitudinal magnetism is shown figure 759 induced, so you can insert with a piece of the transverse cracks and general magnetic particle inspection satisfaction for detection of the cracks of the subsurface cracks that are not more than 1/4 inch below the surface. Type of magnetic particle inspection with the commonly used the Navy, the portable low voltage unit that have the maximum magnetism output of the 100 amperes and 1000 amperage. Either alternating direct current is ready to operate the plug with the voltage supply specified by the manufacturer. The unit consists of magnetism current source and control melting metering 3 and 10 foot lengths of flexible cable. The prod kit. Prod kit includes insulated prod grip fitted on the off the relay with a current control switch post. Pair of heavy copper contact prods, 2 5-foot lengths with flexible cable. Cable fittings are designed to either end of the cable connected by the unit's prods. Any other cable, the 3 outlets front of the unit make the changing and alternate direct current, vice versa, very easy. Outlets are labeled as follow. Left is AC with the center common, and right is DC. One cable allows the plug to be into the common outlet, while the other cable is plugged either with the AC or DC outlet, depending upon the type of the current the test requires. The most of the work alternating current magnetisation effectively locates fatigue cracks, similar defects sitting through the surface when you require more sensitive inspection of the defects to detect defects below the surface of the direct current. You can use the unit with the alternate direct current either with the 2 ways and with the prods attached to flexible cable with the contact with the current into the pass into the out of the portion of the test piece setting with a circular magnetism area between the prods and its contact point, shown figure 758, and 2 with the flexible cable to wrap around the work and to form a coil. Induce longitudinal magnetism of the part of the workpiece with the shrine with the coil cable, although you can use the 2 methods with the prod method with the probably easier to apply. Most instances with the effects of the shear with the detect surface effects when the prod, however, the one small area of the test piece that can be magnetized at one time. Magnetized area limited with the distance between prod contact points and a few inches on each side of the current path. Check with the entire surface you must test and adjacent to the area of the change with the location prod contact joint points. Each of the test piece must be inspected twice, once for the current passing through the metal in one direction, through the current passing through at a metal direction, with the right angle in the direction of the first test. One of the advantages of the prod method is the current that can easily pass through the metal in any desired direction. Thus, given an area of the suspect magnetic field of different directions can be induced during the test. Prod method accomplishes adjusting the current output suitable for the magnetism and testing of the particular kind of metal the current setting produces depends on the distance between the prod contact points. The prod kit supplied with a unit space between the prod contact points of 4 to 6 inches. Current setting at between 300 and 400 amps. Satisfaction material thickness less than 3/4 of an inch. When materials are over 3/4 inch, 400 to 600 amps with the prod contact points closer together, the same magnetic field force can be obtained with less current. With the prods constantly in the same space, more current will induce greater field strength. After adjusting the unit in place for the prod position, have firm intact with the metal and turning on the current with the apply with the magnetic particle with the tester with the duster bulb with the look at the indicator pattern with the current still on. Remove the excess particle with the tester with the blower bulb with the complete with the inspection. Do not move the prods until after the current has been turned off. To do so could cause the current arc resulting in flash similar to the overcurring in the arc welding. Or when you magnetize a particle inspection, hairline cracks are otherwise invisible or readily located unmistakably outlook of the defect. Large voids beneath the surface are easier to detect, with small voids by any of the defect below the surface more difficult to detect than one extends through the surface too, since they False indicators frequently occur, but they must be able to interpret the particle indication occurs. Factors that help the interpreter of the test results include the amount of the magnetism current applied, the shape of the indication, sharpness of the outline, width of the pattern, the height of the buildup of the particles. All of these characteristics do not determine the seriousness of the fault. They do serve to identify the kind of the defect. The indication of the crack, sharp, well-defined part with magnet particles have a defined buildup. The indication produced with the relative low magnetism current seems to be relieved by a straight, sharp, fine. The indication builds up the particles relatively weak, with the magnetism current must be higher than they required to detect cracks. Small porosity, round indentation, or similar defects are difficult to detect with the inexperienced inspector. High magnetism currently continuously applied usually required the particle position. These defects fuzzy in the outline would have been medium buildup. Specification governing the job determining whether or not indicated defect was to be chipped the ground out by repaired welding. Surface cracks are always removed and repaired. Indication subsurface defects are detected with the magnetic particle inspection evaluated by the inspector. The indication of the position stamp policy is to ground and chip down to the solid metal, make the repair unless the inspector can differentiate accurately between true and false. Indication of the use of magnetic particle inspection should be restricted to detection surface defects for application almost foolproof. After indication defects have been repaired, show the re-inspect for the area that ensure the repair is sound with the final step of the magnetic particle inspection. Demagnetism of the workpiece, especially important. The workpiece is made with a high carbon steel. Demagnetization is essential when using direct current to induce magnetic current. However, there is not necessarily the alternating current when used in the test. In fact, even the demagnetization procedure involves the placing a workpiece in an AC coil or solenoid and slowly withdrawing it while current passes through the coil. Demagnetization can be accomplished by the portable specialized demagnetizer not available. The demagnetizing portable unit form a coil, flexible cable around the workpiece. Ensure that the cable is plugged into the unit by the delivery of alternating current. Step of the current with the regulator delivery with the current identical with the inspection turning of the unit. Gradually decrease the current until the ammeter indicates zero. With the large pieces they may be necessary to magnetize a small portion of work at a time. A check for the presence of the magnetic field may be made by using small compass for the deviation with the need of the normal position with the compass itself near the workpiece. Indication of magnetic field that is present. Also, you can interest call with the field indicator check for the presence of magnetic field. The instrument usually comes from the magnetic particle inspection unit. Liquid petroleum and penetration inspection. Liquid petroleum methods. Liquid penetration methods are used to inspect for the metal of the surface defect of the similar to the reveal with the magnetic particle inspection. Magnetic particle inspection can relieve subsurface defects. Liquid penetration inspection reveals only the defects that are open to the surface. 4 groups of liquid penetration presently with group 1 dye penetration, non-water washable. Group 2 water washable dye penetration. Group 3 and 4 fluorescent penetration. Carefully those instructions given at each step of the penetrations for the sum of the difference of the procedure. Safety precautions require various penetration. Before using liquid penetration, inspect the weld. Remove all slight rust, paint, and moisture from the surface. Extract with a special finish if it's required. If it's not necessary, the ground of the weld surface as long as the weld surface meets applicable specifications. Ensure the weld contour blinds into the base metal without undercutting. With specific finish is required whenever the liquid penetration inspection before the finish is made. Enables you to detect defects extended beyond the final dimension. Must make with the final liquid penetration inspection after the specified finish has been given. Before using liquid penetration, clean surface of material very carefully, including areas next to the inspection. You can clean the surface of swabbing it with a clean, lint-free cloth saturated with non-volatile solvent, or by dipping the entire piece into the solvent. After the surface has been removed and cleaned, and remove all of the traces of the cleaning material. And extremely important, remove all dirt, grease, scale, lint, salts, and other materials to make sure the surface is entirely dry before liquid penetration. Maintain the temperature for the inspection of the piece of liquid penetration range of 50 degrees to 100 degrees Fahrenheit. Do not attempt to use liquid penetration when this temperature range cannot be maintained. Use an open flame and increase the temperature because some of the liquid penetration materials are flammable. After thoroughly cleaning and drying the surface of the liquid penetration spray or brush penetration, dip entire piece for the penetrant to allow the penetrant to soak into all the cracks and the crevices of the other defects are open. The surface to keep the surface of the piece wet within the penetration for the minimum of 15-30 minutes, depending on the penetration being used. After keeping thoroughly wet with the penetration required with the length of the time, remove the excessive penetrant with the surface with a clean dry cloth with absorbent into a paper towel with a dampened cloth and clean lint-free material with the penetration. Remove the wipe of the remaining excess penetrant test over the next allow the test surface to dry with the remove of the normal operation wipe dry or dry with a clean lint-free with the absent material dying sun surface to avoid contamination with the oil, lint, dust, and other materials that would interfere with the inspection. After surface is dry, apply another substance called the developer. All the developer powder and liquid to stay on the surface a minimum of 7 minutes before starting the inspection, leaving it no longer than 30 minutes for thus allowing 23 minutes to evaluate the results. Alright, shows liquid penetration inspection, penetration surface keeps crack, excessive remove, clean removes the penetrate from the surface but not to crack. Developer draws penetration from the crack. The following particles take place for the dye penetration. First, penetration is applied with the surface of the material will seep it into the passageway. Open the surface as shown in figure 760 view A. Penetration normally red in color, like the penetration of the oil. Seep of the crack, the crevices of the opening of the surface is next to the excess penetration removed from the surface of the metal penetrate remover to lint-free absorbent material from only the penetrant on the top of the metal surface is removed in figure 760 view B with the leaf of the penetrant has seeped into the defect. Finally, white developers applied with the surface of metal as shown in figure 760 view C with the developers absorbing material that actually draw the penetration from the defect. Therefore, the red penetrant indicates the white developer represents the defect of the area. The amount of red penetrant drawn from the defect of the areas indicates the size and sometimes type of the defect when using the dye penetrant. By penetrance, lighting of the test area must be bright enough to enable you to indicate the effects of the test and surface. Indication you're doing so the liquid penetration inspection must be carefully interpreted with evaluated. Almost every inspection most something significant indications are present. Most of these resolve the failure to remove all excessive penetrate from the surface at least 10%. Of all indications must be removed with the surface that determines whether the defects actually present, whether the indications are the result of the excess penetration. When a second inspection does not reveal the indications some locations, it is useful safer to assume the first indications were false. Remove all penetrate inspection materials as possible. Final inspection has been made. Water soluble unless appropriate. Some of the liquid penetrant materials are flammable. Do not use them near open flames. Do not apply them to any surface with a temperature higher than 100 degrees Fahrenheit. In addition, many flammable, many solvents are poisonous in vapor form and highly irritating to the skin in liquid form. Radiographic inspection. Radiographic inspection method of inspecting weldments using the rays that penetrate through welds. X-ray, gamma rays are two types of waves. Waves that use the process of the rays pass through the weld and one onto the sensitized film with a direct contact back of the weld. The film is developed in the gas pockets like conclusion, cracks, and pore penetration will be visible on the film. Because of the danger of these rays, only qualified personnel are authorized to perform these tests. As CBs, you will rarely come in contact with these procedures. Ultrasonic inspection. Ultrasonic inspection testing high-frequency vibrations waves to locate and measure the defects in the welds can be used with both ferrous and non-ferrous materials. This is extremely sensitive to the system located with the fine surface, subsurface cracks, or other types of defects. All types of joints to be tested. Process for the high-frequency impulse jack with the surroundings of the weld. With a good weld, the signal travels through the weld. The other side is then reflected back and shown on the calibrated screen. Irregularities such as gas pockets like inclusions cause the signal to reflect back sooner and was displayed on the screen. There's a change in depth which use this system. Most of all the type of the materials can be checked for defects. Another advantage of the system is that it's only one side of the weld needs to be exposed for the test. Alright, eddy current testing. Eddy current testing is another type of test with electromagnetic energy to detect all weld deposit effect. Both ferrous and non-ferrous materials. The CBU will rarely use this type of testing in the field. Alright, eddy current testing operates the principle of whenever the carrying a coil with a high frequency alternating current placed next to the metal, electrical current is produced with the metal with the induction current is called an eddy current. Test piece exposed with electromagnetic energy being played with a near high frequency as an AC current coils. Difference of weld changes in the impedance of the coil that is indicated with the electronic instrument. When the defects show up, the change of the impedance of the defect is shown in the amount of the change.